For lesson 81, we're going to take a look at some circles. We're going to be looking at the central angles that can occur within them, and then we're also going to be looking at the arcs, the outer edge of the circle when we intercept those. To begin with, for example number 1, they want to draw a circle with central angles that divide the circle evenly into thirds. So what we want to do is we want to create 3 equal sectors that make up this entire circle. So in order to do that, we need to go back to a concept that we know about circles and the fact that there are 360 degrees that make up a circle. And what we want to do is we're just going to take that whole 360 degrees and we're just going to divide it into however many pieces that we want to. In this case, we want to divide it up equally into thirds. So we're going to take that 360, divide it by 3, and as a result, what we come up with is 120 degrees. So, at this point, we'll establish our center of our circle. We begin by just drawing a radius from the center out to the outer edge. And what we want to do is go ahead and draw in 120 degrees. If we had our protractor, we would place it and we would find that the 120 degrees is roughly at that point. Another 120 degrees would be roughly there. And then we have this third sector over to the left that would create the last 120 degrees. So 120, 120, 120 gets us a total of our 360. If we want to divide a circle up evenly into fourths, we would take that 360 and divide it by 4, and then we would find that it comes up with 90. And that's where we always get our x to occur right in the center. For example number 2, we're given one of the central angles to be 50 degrees and we want to find the measure of the other angles. So if we take a look at the diagram here, the first one that you're probably going to choose is the angle y. And we know that the measure of angle y is always, because it's opposite of the 50, those two angles are congruent. So the measure of angle y is going to be 50 degrees. Again, we call those being vertical angles or opposite angles. And lastly, we got to find the measure of angle x and z. If we focus on finding the measure of angle x, notice that 50 degrees that they give us and the measure of angle x, they form a straight line, which means that angle x and the 50 are supplementary. And we know that there's 180 degrees in a straight line. So the measure of angle x is going to be equal to 180 minus that 50 degrees. So the measure of angle x is going to be equal to 130. And if we identify that to be 130, now again we can go ahead and determine that the measure of angle z is going to be the same as the measure of angle x. Once again, because they are vertical angles, they are opposite one another. Therefore, the measure of angle z is going to be 130. So if we take a look at this diagram, you're always going to have the idea that, regardless of how many angles you have, all of those angles are going to add up to 360 degrees. We could check that if we wanted to, but we would find that they do. And also we have this idea of a straight line having 180 degrees. Therefore, 130 and 150 will get us that sum. Something else that we need to talk about in this lesson is dealing with arcs. An arc is nothing more than the outer edge of a circle. It is the portion of a circle that's intercepted by a central angle. If we take a look at the diagram at the right, we have 3 points that fall on the edge of the circle. And the first arc that we're going to start with is called a minor arc. Now, a minor arc, we call it minor because that arc measure is going to be less than 180 degrees. So if we take a look at the arc AB, and we'll go ahead and use our shorthand notation, the little curve over the symbol of A and B just indicates that that's the arc or the outside edge of that circle. Okay? So a minor arc less than 180 degrees. And an example of that would be the arc AB. Just 2 endpoints of that arc. Major arc if you haven't guessed already, major arc is when we have an arc measure that's going to be greater than 180 degrees. Therefore, if we start at B and now we go the opposite way, we go through the point C and back to A, the arc that we have in red there would be considered a major arc because clearly that arc is bigger than 180 degrees. So a major arc, that is an arc that is greater than 180 degrees. And an example of that arc is the red one that we just placed. Now we can't say that it's just arc AB because then there's no way to distinguish the difference between the red one and the green one. So anytime that you do a major arc, you have to include 3 points. Begin with one of the points that it ends with, and then go through a point that goes through that arc, and then finish with your ending point. So when you identify a major arc, you need 3 points: where it starts, what it goes through, and where it ends. A minor arc is just 2. It's just understood that we're always going to take the shortest distance between A and B. That way, with a minor arc, we only have 2. So lastly, for example number 3, tying a couple of different ideas together. For part A, we want to know what is the measure of arc AD in degrees. So if we identify AD, here it is on the outskirts of the circle. The arcs actually have a measure, and the measure of that arc is simply the measure of whatever the central angle is. It's given that the central angle ABD is 60 degrees, therefore the measure of AD is going to also be 60 degrees. So they keep that the same for us. Part B, what fraction of the circumference is the arc intercepted by ABD? Okay. So we could find the length of this arc and divide it by the total circumference of the circle. We're actually going to do that later on in part C, but for right now, what we really want to focus on is the 60 degrees that is given to us. Because again, we're going to come back to the idea that there are 360 degrees in a circle. So, this arc we know takes up 60 degrees, but the total circle itself is going to have 360 degrees. So there is our part divided by the total amount. We factor out our 10 to get down to 6 out of 36. The degree symbols also cancel out. 6 over 36 reduces down to 1/6. So if they want to know what fraction of the circumference is intercepted by an arc, all you have to do is take the angle measure at the central angle and divide it by 360. Lastly, what is the length of the arc in terms of pi? Okay, length of the arc. The only thing that we have to use right now is the fact that we have our old our formula for circumference, which is pi times diameter, or diameter times pi. Let's go ahead and write it that way. Diameter times pi. And what we want to do to begin with is we're going to start by finding the entire circumference. And then what we're going to do is we're going to go back and we're going to figure out, okay, what is the fraction of that whole circumference that we have? And then that'll give us the length of that arc. So, it is given that the radius is 6, which means our diameter then is going to be 12. They tell us to leave it in terms of pi, so I'm not going to plug in 3.14 or 22 over 7. I'm just going to leave it as the pi symbol. So this is our total circumference right here. But we don't want the total circumference. We want to go back and we want to find the length of the arc. We want to find the distance between A and D on the outskirts of the circle. Now we're going to go back and use our answer from part B because we know that that arc takes up 1/6 of the circle. So the last part, we want to know what is 1/6 of that 12 pi. So yeah, you're going to go ahead and take the 12 pi and divide by 6. If you want, you can put it over 1 and view it this way as well. But in the end, that arc length is going to be 2 pi units long. And again, that's using the fraction of the arc that we had to work with. Practice set problems that we need to work on are going to be A, B, and C.